Well, here is a problem, and in that problem we try to use the chi-square test, and the problem can be solved by using the chi-square test. And look at this problem. The standard deviation of marks obtained by the students of statistics department of the university is 9.5. Okay? A professor believes this value to be less. He samples marks obtained by the 50 students and finds that the standard deviation is 7.5. Does this sample provide enough evidence to suggest that the true standard deviation is less than 9.5? Test at alpha equal to 0.05. Okay. So, in this problem, it is clear that there is two standard deviations. One is population standard deviation and another is the sample standard deviation. So population standard deviation is 9.5. Okay. So, and the sample standard deviation is 7.5. So what is the null hypothesis and what is the alternative hypothesis? The null hypothesis here is 0 is 9.5, sigma equal to 9.5, and alternative hypothesis sigma less than 7. Sigma less than 9.5. Okay, sigma less than 9.5. So look at this. So here is the null hypothesis, and from this standard deviation you can have the variance. So you can write it this way. So null hypothesis is that it is equal to, that is the standard, that is the variance in the data is 9.5 and variance is less than 9.5. Okay, as the professor of statistics claimed like that. So you have to prove, you have to check the null hypothesis, and whether you accept or reject. Is there enough evidence to reject the null hypothesis or not to reject the null hypothesis? So the formula here is that for chi-square equal to n minus 1 s square, that is standard deviation of the sample, and sigma square, standard variance, that is the square of the standard deviation of the population. Okay, so it is clear that what is the value of s? Value of s is 7.5, and what is the value of sigma? 9.5. What is the n? N is 50, and n minus 1 is 49. So if you put the value in this way, that 49 7.5 whole square divided by 9.5 whole square, and after simplification you can have the value that 30.54. Okay, so now we have to consider this, that whether it is a left-tailed chi-square distribution or right-tailed chi-square distribution. Whether it is a left-tailed chi-square distribution or right-tailed chi-square distribution. So look at this. This is the alternative hypothesis. As if there is a less than sign, so it is a left-tailed chi-square distribution. And left-tailed chi-square distribution is like this. Okay, so this should be the critical value, and this is the table value. And table value, what is the table value? On the basis of the degrees of freedom 49, the table value is 27.99. The table value is 27.99. So this is 27.99, and on the basis of the 49 degrees of freedom. So clearly 30.54 is greater than 27.99. So this is the rejection region and this is the acceptance region. So 30.54 is greater than 27.29. So we cannot be able to reject the null hypothesis. Or you can say we do not have enough evidence to reject the null hypothesis. What is the null hypothesis? The null hypothesis is that variance in the data is 9.5, is equal to 9.5. So we accept this. We cannot be able to reject this hypothesis. Okay. Well, so this is the prime focus of this lecture, and I hope you have understood this problem and the application of the chi-square test. Thank you for enjoying this lecture.